All right, so welcome to the second part of 10.2. Continue. Mass and center of mass of a thin wire. If C is the piece of wire, and rho x, y, z is the density of the wire. Now to put fx, y, z here is the density of the wire at a point x, y, z. Then, well, we learned from last time that the mass of the wire is that would be an integral. Right? You get the sum of all the smaller mass over the curve C. And then we can also figure out the center of mass. X bar, Y bar, Z bar, where X bar is very similar to what we did in the previous chapter. X F X Y Z ds, and then take it, you divide by the mass here. So Y bar is going to be y f x y z ds, and z bar is one over m then I can find formulas very similar to this one. We did it. I remember we did it. It's for 15.4. Mass, center of mass. What's the formula? Look at this thing here. Huh? Moment of masses. It's very similar. This is the center of mass. Do pretty much the same thing. Okay. So here come one problem, right? You got to be able to figure the center of mass. One, find the center of mass of a wire in the shape of a helix where x equal to sine t, y equal to 2 cosine t, and z equal to 3 t. T go from 0 to 2 pi. Okay. We're gonna sketch out the helix here. Of course, using GeoGebra. Get to GeoGebra here. expression. Variable, stored in variable and variable. Oh, shoot. What's the xt? 2 sine t, 2 cosine t, 3t, t, 0, 2 pi. Yeah. I need to 2 pi is going to be up here, up to 6. Okay. So this look like it. Yeah. You just got to make it look a little nice there. Okay. Yeah. Somehow I cannot. Okay. So this is good. I'm going to copy the whole thing here. We don't have density here. Huh? Let's density be and density is a constant k. Okay, we have a density, so we can do it. Integral over the curve C, density ds. So the ds here, you have to work out the ds here, guys. And I have to do again x2 sine t x prime is the 2 cosine t, y2 cosine t, y prime is negative 2 sine t, z is 3t, z prime is 3, and then the ds is gonna square root of well, x prime square plus y prime square plus z prime square dt. Root of 2 cosine t square plus minus 2 sine t square plus 3 square dt. And this is going to give us fortunately the cosine square and the sine square they're gonna add them up to 1, so we have a root of 4 plus 9 dt, so that will be a root of 13 dt. Yeah, so that's the ds right there, huh? Parameterize the curve C. Well, the parameterization is already right there. It's given in the problem. Zero to 2 pi k root of 13 dt. And then from here, you see that it's just 2 pi k root 13. So that's the mass there. Huh? And I have to do the x bar, y bar, z bar. X bar is the 1 over the mass, integral over the curve C, x density times arc length. Okay, same thing here. In order to do this one, you got to parameterize C. So parameterize well, we already know the mass, so it's going to be 1 over 2 pi k root of 13, 0 to 2 pi. When you parameterize x is 2 psi t k. Oh, the ds there. Yeah. I got to sub it into a root of 13 dt. Yeah. Sub everything in here. Root 13. Actually, let me write this thing here. So the whole thing here is just going to be a 0. How nice. Y k ds parameterize this thing. Pretty much the same thing. Two pi is the 2 cosine t k root of 13 dt. 2k root of 13 over 2 pi k root of 13 integral 0 to 2 pi cosine t dt. 0. So x bar is equal to 0, y bar is equal to 0. Now it's just going to be a z bar parameterize it, and 2 pi k root of 13 0 2 pi z is the 3t k root of 13 dt. Oh yeah, this one you got to integrate this thing here. It's not gonna be 0 no. 3k root of 13 over 2 pi k root of 13 0 to 2 pi t dt. So as you can see, yeah, what do we have here? We have a 3 pi. So box them up, and the center of mass is 0, 0, 3 pi. Two. So there's 3. Curvy wall fence. There are 2 of them because you got to project it on the x, y axis. Okay, here come In the last lecture, we learned that when you integrate a curve, right, with the respect to only dx there, what you get is that you get a projection of the area onto the xz plane. This is the same as the shadow of the curvy wall onto the xz plane. The projection is just the shadow. Okay. And we also see that fxy dy is the projection of area onto a yz plane. Might as well sketch one of them for you to see, or manage to sketch. Okay, let me do a sketch here so you can see that. Okay, let's say that you have this curve C. It look like C here, and then up here is going to be a same C. Okay, here come the surface. And then, of course, it does have a beginning and an end. Okay, you see, this curvy wall. We want to do the integration with respect to x. So the only way to do integration with respect to x, that's going to push this onto the x-axis there. You push it onto the x-axis, right? You're gonna get something like this. This thing right here is the integral over the curve C fxy ds, right? But then this one is integral curve C fxy dx. If we have integral C pxy dx and integral C qxy dy, then you can combine them together. You can add them up. C 2x dx plus y dy, where C is the unit semicircle. Above the x-axis. From 1, 0 to nib 1, 0. In video game, you will say that these concepts will be useful in a video game. It is just like an image right here, right? You project it onto the XZ plane and the area. It would tell you how much memory it takes. Then later on, we're gonna study about the normal factor, and then you can see that you can shine the light onto an object. You will see which part of the object is gonna be shiny, and then which part is not gonna be shiny. It's time to parameterize this thing here. Parameterize the semicircle. So if it is part of a circle, what do we use to parameterize here?
X squared plus y squared equals r squared.
Look like we have it. We have everything here, right? Now you can do the substitution. I'm gonna write this thing out right here. C 2x dx plus y dy. You're gonna parameterize. We know t go from 0 to pi. X is the cosine t, and dx is negative sine t dt. Everybody okay with this? You just parameterize and then you do substitution. Y is sine t. dy is the cosine t dt. So that's what you can factor the dt here. So what do we have? We have a negative 2 sine cosine plus sine. Cosine is going to be a negative sine t cosine t dt. U cosine t. Meaning that's going to be a du square cosine t dt, and the integral of u is going to be a u square over 2, so it's going to be a negative 1 over 2 u sine t, so sine t square 0 to pi. Negative 1 over 2. Sine up pi square minus sine up 0 square. Now what do we have here? You just have this to be 0. Sine of pi is this. It's 0, and then it's 0. So all right. Yeah, let's see if you guys are able to do this one here. We have about 4 minutes. You guys can do this. Try this out. It's not that that bad. It should be very fast for this problem here. Evaluate y dx plus z dy plus x dz, where c is a line segment from one point to another. 345, 340. The answer is -15. If you do this thing correctly, that means you are good.